Hi, this is Tim Fairfield, Keysight Technologies. In this video, I'm going to be talking about the LTSSM features of our protocol analysis tools, the exercisers and the analyzers, how to get set up, how to get going, and how to run some state analysis and look at some of the results as part of your testing. Let's get started. What we'll notice here in the setup is that I have two exercisers in this case. One's just going to act like a DUT. The other one is going to be the host side, if you will. I've got one plugged into the backplane. This is the Keysight backplane. So this is a passive system. It just supplies power, clocks, and resets and the required signals to get cards to come up. And the analyzer is plugged directly in. And on top, I have connected on the bracket one of the other exercisers. So one will appear upstream, the other will appear downstream. The key thing is there, because of the weight of the exercisers, and if you're using a bigger card, you will want to be using the supportive bracket that is included. That's a good note. And then when you're powering up, it's always good practice to power the backplane up first, start up the power for the other devices. I like to have them on a power bar so that they all come up together, and wait about 20 seconds after powering the backplane before starting the other devices. And another thing is a good practice, once they're up, press the reset button at least once. That seems to get things going really nicely. I did talk about in the last video about running the cleanup utility. That is a good thing to do. If you had exited the system the day before and powered things down and forgot to shut off the software, some resource may be left open. That will give you some problems. So the best practice is to run the cleanup first after you've powered everything up. And then we'll start with launching the different modules. I'm going to show you how to do that next. So when launching, I've talked about this before, I like to launch concurrent versions rather than launch everything under one roof. When you're running multiple instruments, it's actually easier to flip between the windows, and then you can have full screen real estate for each one if you want. If you have multiple monitors, even better. So what I like to do is quickly launch 3 sessions, one for each exerciser, one for each analyzer, and then select their appropriate hardware. For the exercises, it's pretty straightforward. For the analyzer, we do have a choice to make when we're launching, whether we're going into full LTSSM mode or we're doing the TLP mode, which also can do LTSSM. So when you're bringing up the analyzer, we can see here we have the option to either run LTSSM or run the other FPGA version, the TLP. So one thing I'd like to mention is the differences between those two builds. So the analyzer LTSSM is more optimized for LTSSM. It's optimized for faster speed changes, supports triggering on speed change events, order set triggering and capturing, but does not support TLP or DLLP layer triggering and capturing. So while the analyzer and DLLP option is more optimized for the TLP, DLP, which supports ordered set and trigger capturing, it does not support triggering on speed change events. For this, the LTSSM image is optimized. It's having order set compression to reduce the capture memory depth. So that's another advantage. And it has special optimizations to follow speed transitions as quickly as possible. So in this case, we're going to be using the LTSSM mode for this demo video. Okay, so I've brought up, we can see that each of these protocol exerciser, the analyzers here, we have 2 exercisers, and we're going to just focus on the exercisers right now to make sure they're communicating with one another. They can do both functions. The one on the right, I'm going to leave as upstream, and that'll be like my DUT. The one on the left, I'm going to have it talk downstream, and we'll see how that goes. And let's try a link up. So essentially, I've pulled out the hardware status window, so that's important to keep an eye on as you're doing this. So that's how you open this up. Just click here, do that, and bring it over. And we want to start on the remote side. Doesn't really matter, but we'll have this ready, and it'll be advertising ready to go. And when we click this, it should train up to 32 gigatransfers. Everything goes well. And yes, it did. And it's a by 16. So both are advertising that. We can change the link width right now. If we'd like to, we could go to make it a by 4 device or just advertise by 4, and let's relink train. And now we have by 4 32 gigatransfers per second. Let's go back to the by 16 as well and just retrain that. So we'll leave it at the 32 gigatransfers for this. by 16, 32 gig, and both sides are doing that. So that's good. So that gives us a view of what's happening. Next, we could change link widths or the autonomous speed change and have it only go to 8 gigatransfers and check that and capture that. But what I'm going to do is go into the LTSSM test cases, a very useful tool. So I'm going to pull this over a little bit further so we can see a bit more of this window, and we'll see its partner over here, the DUT. We can capture the state transition, so we can say, what state are we in right now? So let's do that. We're going to clear the log. So it's good to clear the log so we know where we're starting at. And I'm just going to check, are we in L0? Yes or no? Yes, we are in L0. Good. Let's do from 32 gigatransfers, and we're going to do lower speed change. So we're going to 32 down to 2.5 gig. From 32 to 16 to 8 to 2.5. Let's go ahead and try that. And it passed. So what happened here? So first of all, if you want the details, in a nutshell, we're essentially doing a sanity check for the prerequisites that it's active, and the active state and the link speed is this to start. And then we want to observe the following checks, and it'll go through these. And we get timestamps for everything so we know how long it took. So once we go over to analyzer mode for each of these stages, I'll be able to get a better idea of how much data memory I'm going to need to get through all of this and capture all of these. But again, this is kind of the essence of the LTSSM test cases. A lot of different options here. Let's go in the opposite direction. Let's do a speed change from 2.5 up to 32 only through one phase. So let's try that. Oh, I pressed the wrong one there. Okay, let's go back down. Let's do a speed change down. So it did autonomous speed change. So I did that wrong. What I meant to do, let's go back to the state we were just in. Okay, we're past, so we should be in this state. You can always check if you don't know where you're at right now, capture state transitions. We can clear the log, capture the state transition, run that, see if we're L0. Yes, we are. Now we're going to start link training 232, so from 2.5. So let's click this one. Yes, and we made it to 32 and we passed. And we see each of the states we went through the recovery L0 states, through each of those L0 states, and it checked the link was up and we're at 16. So that's how you get the exercisers working. And there's a number of other tests in here, as I said before, and you can also change autonomous speed change here. You can disable or enable the bypass modes. Don't forget you have equalization values. Now, the other thing is when you're investigating all this stuff, we also have an equalization window. What happened? How did we get through each of these values here? So these are the type of things you want to probably look at. That's a sanity check on connecting to a DUT. I've used another exerciser as a DUT, but you could use your DUT in this situation. So that covers the getting started. You can do a lot of testing here, and it's also very fast to try all these test modes. Okay, now that we've established that, it's time to bring up the analyzer, and let's first of all see where we're at. So just fire one of these off, run that. This is right out of the box, so we are seeing things. We can do a traffic overview, all that. But let's get started. Probably nothing exciting going on here right now, but we can do a compute on the LTSSM overview. We're already at L0 Gen 5. Okay, so we want to capture those transitions going in there. And in order to do that, I need to look for something that I can trigger on. So I'm going to use speed change, and then I'm going to see where I get. The other thing I want to do is this trigger position. If I do it in the middle, I'm going to get everything before the trigger and everything after. I want to optimize my memory to basically capture pretty much everything and apply that, leave that. And in the memory, that's the wrong selection. In here is where we get the memory depth. So this is set for 1 meg. I know just from my own knowledge that that's probably not going to be enough information. I'm going to take a stab at it and say 512 megs might give me everything I need to get a full speed through all phases like we just did. So I'm going to apply that and say, okay, now what I care about, what I can see is I'm going to put this on the side so I can see the status down here when I'm ready. And I'm going to want to put the 2 downstream one on this side, and we'll leave the other one hidden because we don't really need to see that. So I'm going to get this ready to go and wait till it says running and waiting for PCI Express trigger. That's exactly what I want. I'm in by 16 32 giga transfers. I'm going to initiate, we're we're going to do a lower speed change. That's exactly what we're going to do here. Let's clear the log. So we have a nice clean log. And we want to be able to see what happened using the analyzer. Okay, so let's go ahead and fire that off. It says triggering and processing. Okay, so we're going to let it do its thing. It's going to process and put the data on the screen when it's ready. And there it is. So we did get this. Now, one quick check I want to do is, did I get everything all the way down to Gen? I only made it to Gen. So I've got 7 milliseconds of data. That's probably telling me that I did not get everything I wanted. We only went down to Gen 4. Now, in this case, we made it all the way to 2.5. So why is that? So we have only 7 milliseconds captured here, which means I'm going to have to capture a lot more data. And let's go through. We've got, so that's 3 milliseconds already, not including other things that happen here. So 20, 17, 37, 39 milliseconds is probably what we're going to need. So I need about 3 times that now. So I'm going to have to, let's take this, let's speed change this down, change it to 32. Let's get it all back to 32. And then we're going to try this again. But this time I'm going to have to tweak my analyzer settings. That's what I'm going to want to do. So I get more of a trace in there. Maybe 4 times what I did, maybe a 2 gig. Let's see how much. Oh, let's try a 1 gig. Maybe we'll get it with this. Apply. Oh, I didn't enable compression. That's the other thing. Maybe that will help us too. Okay, let's do that. Let's get this armed and ready to go. Processing, running, waiting. And then we're going to fire off our down speed. It's waiting for the trigger. Let's clear this, clear log, and it's filling memory. Oh, now compression. Now it's processing. There you go. And we definitely are at 2.5. So we got there. We could always, like I said before, we can check the capture state transitions while we're waiting. All right. So we started at Gen 5. We are all the way down to Gen 1. So we got everything. That's good. Now, maybe I went a little, probably because I turned on compression now, I don't really need so much. Yeah, it actually got through this fairly quickly. So we could have optimized that by turning on compression, but okay, let's get a compute on the LTSM. I'll click on that. It's already there. We could be in traffic, but we'll click there, compute. Now, this is going to take 70 seconds of processing, and let's see what we get. We should be able to see the different states, and this is in the compressed mode, I believe. It's processing almost 2 million packets. All right, we're at the end, counting down, 6 seconds left. Boom. Okay, now let's make this big so we can play in this window a little bit. So we went from Gen 5, we went from L0 state in Gen 5 all the way to Gen 3 down to Gen 1. So this is how it made the transition, Gen 4, Gen 3, and then Gen 1 speeds. So we can jump ahead and look at what happened at each of these phases, and we can see the different states and where things are in this process. We can also, if you want, you can do traffic overview processing. And once it's processed for LTSSM, it's going to be very fast. You can jump ahead and look at these as well. Go to an overview here as well. Now, one thing you can do is add more information. So we want to insert a column after, and I want to go to packet fields, and I want to look for cursor coefficient value. So that's one thing you can put in here, and we can jump ahead to each one of these cursor coefficients. So again, you can customize these, and this stuff is informational for LTSSM. You can see what was negotiated in each of these stages as well. So that's something else. I want to show it just one more capture because these things can take time. I did have compression turned on, but what we're going to do now is do a hot reset. So let's move that over here for now. We're going to train to 32. So let's just do one of those. There we go. We're at 32. So I want to capture, if I can do this, processing. Let's get this ready. We can go down and let's do a hot reset. Redirected to hot reset from L0. So let's select that one. Let's clear this log. Maybe this time what we'll do is go in and turn off compression. So apply. And let's see what we get with that. So wait till this is running and ready to go. And then I'm going to set this one to go. This is the directed from hot reset. Let's run that. So 84 milliseconds. Hope I have enough memory stored, but let's see what happens, because I turned off compression, remember? And as it's processing, it'll just take a little bit of time. There we go. Okay, now, how far did we get? We get to Gen 4, but let's compute this. Probably I'll want to go back to compression mode. Okay, and we are here now. We have captured this. We've got our hot reset event that occurred, and we can look at the wait and accept statements, for instance, and it's training down to Gen 4 in this respect. It went down to Gen 1 and then it was coming back up, Gen 3, Gen 4. So I think right now, what state is it in? Let's just check that. Yeah, it came back up. So it came all the way up. So I actually didn't accommodate the amount of time it would take to get back up into Gen 5 state. Let's, just for the heck of it, we'll turn on compression, see if we can capture everything. And I'm going to enable compression this time for sure. We're going to enable compression. We're going to run it again, and we should be able to capture everything. So let's get this guy ready and get ready. Actually, yes. And we're in 32 gigatransfers, and we should be able to fire off a hot reset processing. So we'll let that run. Down, PCI up. And now we're going to do a compute. Yeah, there's more packets being handled here. There we go. And this time, yes, we're back to Gen 5 L0 on both sides. From a Gen 5 down to Gen 1 speed, 3, 4, and 5. So we've got everything captured. We've got the hot reset condition here. We're going back to detect, receiver lock, receiver config, wait start. So you can see in each of these state diagrams as well. So the config link with accept, the wait accept, the complete, the idle. So you can get to each one of these stages and where they're hitting here. So that's kind of a quick overview of navigating, getting around, getting things set up. Another thing that I would mention at this point is once you do have a trace set, what do you do with it? You can save these off. So if you want to save as an analyzer config and data file, this is where you would do it. You can save these. Let me store one to the desktop. Let's see, this PC desktop, and let's call it hot reset LTSSM. Now we can save this. You can save all data. That's what we want, or the data range. You don't have to save everything. If we save that, it saves relatively quickly. But what you can do afterwards is load this up, and you can analyze it later, analyze it offline. You can put it side by side for comparisons. But once you do that, the processing time is very quick. So just leave it at that. But you can open an offline version of this. You open up that window in offline mode. That's exactly what it is. So let's let it run. This probably takes about 2 minutes to save a trace of that size. Okay, it's saved. Let's bring that up. We've got host. There it is on the desktop. What's the size? Let's hover over this. 1.3 gig. Okay, let's open her up. So I can double click on that and it will open up yet another window. And we're doing the offline. This is the analyzer. Okay, I guess at this point, I actually have to open the file. So I open an offline version of that. So we just have to go to the desktop and hot reset and open. Oh, there we go. Okay. So this opened up pretty quickly. I just had to open the offline first. So that was my mistake. But you have the hot reset to detect a receiver config. You can do traffic overview and compute and so forth. And this is the offline data now. So now you can make direct comparisons maybe to another situation, repeatability, that sort of thing. Or you may need it for documentation to show just a good thing to know about. Thank you very much for watching this. We covered getting things started and sanity check on the exercisers, what you can do with the exercisers alone and how fast that is, and the vast number of tests and parameters you can adjust. And secondly, we set up the analyzer in LTSSM mode and turned on compression and saw how fast you can capture and process data. And finally, how to save off your files for later comparisons and for logging issues that you may be having on a DUT that you're testing, or that you want to log some of the successes you have. Thank you very much for watching, and we'll look forward to seeing you in the next video.